In this video, we'll be creating Perceptron using Python and NumPy entirely from scratch. Perceptron was first created in 1957 in Cornell Laboratory. Implementation of Perceptron is governed by some really simple matrix multiplication, where x corresponds to the features and w represents the importance of every feature, which is termed as the weight. Each of these individual features and their associated weight are multiplied and summed together. Something known as predicted value is generated. And this predicted value is then passed on to something called an activation function used to propagate predicted values in a more denser neural networks, especially in the case of classification tasks, which we are doing today. Let's hand code a module that can classify normal and abnormal systolic pressure. Okay, so import the NumPy module and create a class called Perceptron. Let's go about initializing input, output, and weight as matrices to this Perceptron class. Iterations allows us to loop through our training data and adjust our weights and biases. Bias, what's that? A case is possible where the predicted value could be 0 and could be right in few cases. So bias could contribute to this condition and lead us to the correct output. Learning rate just helps us make smaller steps in updating these weights and biases. Let's create some instance variable and assign all of the arguments. Let's randomly create some weights centered around the mean of 0 and standard deviation 0.01. According to the rule of matrix multiplication, the dimension of the weight matrix should be same dimension as of the column of the input matrix. We'll now initialize the bias to 0 and the NumPy array to store the errors. Let's now go ahead and create the method to train our model. A loop to do the iteration through our data and also a variable to store the error each time we iterate. And now we'll pack the input and output matrix into another for loop and take the difference between the predicted value and the true value and store it as delta and scale it using the learning rate. Scaled down version of the predicted error will be multiplied with each of the input feature and updated to the weight matrix, since weight is dependent on the input feature. Bias is then updated and the errors are appended to the NumPy array which we initialized above. Mathematically, this is what the train method is doing. After all the iterations on the data are complete, we'll return our own Perceptron object as itself. Now let's create the predict function which was used in the training method. First, a net input is computed by taking a dot product with the weight and the true input sample and adding bias to it. And an activation function of unit step is used to decide whether the value is a yes or a no. Let's now quickly get some example input and output data of systolic pressure, the values which correspond to hypertension or not. 1 would mean the hypertension condition and 0 would mean a normal. New systolic readings is our testing input data. So to predict for these new systolic readings, we'll quickly initialize the Perceptron object and pass in the systolic training data for which the hypertension values are known. Note that the iterations is initially kept really big. This will be discussed later, and the learning rate is defaulted to 0.01. Spawn in the train method of the Perceptron and then give some logs that would output the predicted values for the new systolic reading. I've kept the number of iterations to 100 for now, and let's run it. Note that the data is really less and the iterations are not sufficient for the model to update its parameters, and hence the predictions will be wrong. Let's try increasing the iterations to 1000. Still not the output we desire. So if you see the sequence of the inputs, the expected output predicted sequence should be 0, 1, 0, 1. Now, keeping the iterations to 10,000, now we see the magic of Perceptron and we get 0101 as the output, as you're seeing on the screen.